Hello everyone. In this video I want to show you this neural network program that I wrote in Python that is able to identify hand-drawn digits. Before I begin, I want to say a few things. The first is that I'm a total beginner at programming neural networks, and if I'm being honest, I don't understand any of the math behind it, so I just let the computer do it. So just bear that in mind. I'm not perfect, the network's not perfect, it'll make mistakes, and I'll demonstrate that later on in the video, so keep that in mind. Second thing is that this is able to identify just single digits, so 0 through 9. So if you gave it something like 16 or anything like that, it wouldn't be able to identify that. The last thing is that I'm just going to be demonstrating the program. So if you don't understand programming or neural networks, don't worry, I'm not going to be explaining anything that you wouldn't be able to understand. Having said that, if there's anyone who would like a little bit more of an in-depth review of how the program works, then just let me know in the comments and I'll be more than happy to shoot a video where I explain how this stuff works, or just kind of in a broad sense how it works. So having said that, let's go ahead and get started. Before I show you how it works though, I need to say a few things, and again, don't panic if you're not a programmer or anything. I won't explain something that you won't be able to understand. So the first thing is, let me tell you what a neural network is. That was a bad way to say that sentence, but you guys know what I mean. So a neural network is basically a computer program that can be trained to do something, in this case recognizing handwritten digits. And the other thing that I wanted to say was that, and now I'm forgetting it, this little string right here. What this is essentially doing is asking the network to find the picture test.png and then guess which digit is drawn on that image, or not guess, but really predict. And it's telling I'm telling the computer that test.png, or I'm telling the program that test.png can be found in a folder called images. So you can see in my project up here, I've got some folders and some files, and if I open up the images folder, if I scroll down a bit, you can see test.png is right here. All the other images are just training images, or images that are used for training data, so don't worry about those. And if I zoom in here, you can see at the moment it's blank. We'll fix that in a minute, but I just wanted you to know what the network is actually doing, because if I didn't tell you that, then it might be confusing as to how exactly it's finding this image. So I just wanted to make that clear. All right, so let's go ahead and give it an image to try and guess. So what I'm going to do is open up this little basically Photoshop alternative. This is GIMP 2.0, and I'm just going to draw a little 7 right here. And I like to draw mine with a slash, so we'll put a slash in there. And then I'm just going to do Control E and export that. And if we go over to test.png, you can see the 7 has been saved. So what I'm going to do now is open up this terminal and then run my program, which is app.py, or app.py, but pronounced py. So it's going to take a little bit of time to execute, not a crazy long time, but a little bit of time. And what I'm going to do is just for this one example, I'm just going to burn off some time by explaining what the average network error is. Sorry. And again, don't worry if you don't understand this. This isn't even important to understanding the demonstration. I just wanted to kill some time. So what the average network error is essentially how wrong the network is. So what it's going to do is look at its training data and then determine how wrong it is and then make corrections. So in this case, you can see it's wrong by about 0.4. That's kind of an arbitrary number at the moment, but yeah. So it's wrong by basically a lot, and then as you can see, as it continues to train itself, it gets less and less wrong, which means it is getting more and more accurate at determining, at least from the training data, what numbers are what. So we're almost done here. I programmed it to train 50,000 times, so just as it gets through the last couple thousand loops, we should see results. So let's see what we get. Just a few more seconds. There we go. So it says that the network thinks that the test image is a 7, which is correct. So now that you've seen it work, let's see if we can get the program to not work. Now it has a tough time distinguishing the number 8, so I'm going to draw number 8, and we'll give it a chance of identifying it. It can identify kind of bigger 8s, but smaller 8s it really can't do. So we're just going to go with this 8. And it usually confuses an 8 with a 6, and I think the reason is because a 6, if I just draw one kind of on top, is kind of similar to an 8 at the bottom. It just has an extra, I'm sorry, an 8 is similar to a 6 at the bottom. It just has an extra little loop at the top. So because my data is very small, my training data set is very small, and because my network is not the best, it probably won't be able to get this, but you never know. If my image is close enough to the training examples of an 8, then it might actually identify it. So let's just check that it exported. Okay, it did. Good. Good. Excuse me. So let's go ahead and run the app. And this time, what I'm going to do is I'm just gonna cut ahead until the network is almost done. I guess I'll just see you on the other side. All right. So the network is almost done training itself. It's just got its last couple thousand training loops to go through. And after a few more seconds here, we should see what the network's prediction is. There we go. So the network thinks the image is actually a 4, which is kind of funny because a 4, if I just draw one real quick, a 4 is not really that close to it. That was a bad 4, but you get the point. So yeah, it guessed it was a 4. I don't really know why, but like I said, network is not perfect, and I'm a beginner, so it's to be expected, and it works decently enough. So there was a demonstration of it not working. And as a last demonstration, let's go for a number that I know it can get pretty consistently. Let's go for a 1. So I'm just going to do this and then just do a little, I guess, feed at the bottom if you want to call it that. So let's export that. And this will be the last test, just to let you know. So, okay, the 1 got saved. And yeah, last test because while I'm recording and running this program, it's kind of putting stress on my computer, so I don't want to do this too many times. So we'll go with 1 more. And the same deal, I'm just going to cut ahead to just when the program is about to finish. So again, see you on the other side. Excuse me. All right, so same deal. The program is almost done training itself, and let's see what it gets. And yes, it was a 1, right? Yeah. Okay. So we're hoping to see it say that it's a 1, and let's see what we get. All right, so the network thinks the image is a 1. All right, so that's good. I'm going to leave it at that because it can confuse other digits with other digits. So like it'll think a 3 is a 7 and then other crazy things like that. So we're just going to let the network maintain its quote unquote decent reputation. I mean, I only did 3 examples, but yeah, we'll leave it at that. So yeah, thank you guys for watching. If you have any questions about this, and I'm sorry, I said that the wrong way around, or at least I was thinking too fast. If you guys have any questions, leave them in the comments and I'll do my best to answer them. Like I said before, if you would like a more in-depth explanation, just let me know again in the comments, and I'll be more than happy to shoot a video that explains this program. But yeah, otherwise, like I said, thank you for watching, and have a good day.